Okay, welcome to this just introductory video on sequences and series. What are sequences and series? So let's just give a little introduction to what these things are. Basically, let's start with sequences. Sequences are just a bunch of numbers, like an ordered list, that follow a certain rule. So if we have 1 and then 9 and 17, why did I choose such awful numbers? I'm going up by 8 every time. And so this is an example of a sequence. It follows a certain rule. Each number is defined in terms of the one before it. There's something going on here. In this case, what's it doing? It's going up by 8. Each time it's adding 8. And so that's what's happening in this sequence. Another sequence might be this. What's happening here? Well, each number is defined by whatever's happening in front of it, but this time it's a bit different. This time they're multiplying by 2 each time, multiplying by 2. So this is also a sequence. These are two different types of sequences here, but they're both sequences. And so when the term before gets added, so when we're adding 8 each time, adding, we call this an arithmetic sequence. And when something is being multiplied, we call that a geometric sequence. And so that's the only difference between those two, but it's quite a big difference. So when it's adding, well, we can also have subtraction, okay? So adding or subtraction, that's still called arithmetic when it's subtracting. We've got that, and then geometric sequence is when it's being multiplied or divided. Those two go together in maths all the time anyway. Arithmetic sequence when they add or subtract, geometric sequence when they multiply. So all those are defined by, you start with 1, you double it, you double it, you double it, you double it. Geometric sequence. So that's our sequences. What are series? Okay, so these are sequences. Sequences there. What are series? Well, series are exactly the same. They're just a sequence where we add all the terms together. Okay, so if we took this this arithmetic sequence up here, then the series would be 1 plus 9 plus 17 plus 25 plus 33 plus dot 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 on forever. Okay, so that's called a series. And because the numbers are all going up by 8 each time, that's called an arithmetic series. Okay, fantastic. And there we've got this geometric sequence here. What would the equivalent geometric series be? It would be 1 plus 2 plus 4 plus 8 plus 16 and on forever, like that. So that's all that is. So that's a geometric series. And that sort of defines everything to do with sequences and series, as long as you understand what we're talking about when we're looking and when we're talking about arithmetic and geometric and what sequence and what series means. That's important to know. Okay, so let's just look at a few other things now. There's sort of two ways to define a sequence. Okay, so let's just look at a sequence. Let's have a look at this sequence here. So 4, 7, 10, 13, etc, etc, etc. Okay, how can we define this? Well, we need to just have a think about a few things first. Firstly, let's let Tn, that just means that's the nth term. Okay, so looking at this bunch of stuff here, that's the first term there, so that would be T1. That's the second term, T2, third term, fourth term, etc. Okay, so the nth term is whatever you're looking at here. So you're going up to Tn, something up here. So you've got some term there, Tn. So first term, second term, third term, etc. Okay, these are all called terms. That's the first thing we need to know. We'll just define a few other things while we're here. The first term, the very first term, we give it the name of A. Okay, so in that case, the first term here is 4. We need to know what our starting point is. So first term is always called A. And in geometric sequences, let's do that again. In arithmetic sequences, what happens in arithmetic sequences? Well, they all go up by the same amount. They go up by the same difference every time. And here we're jumping by 3 each time. And so what we say is that D is the difference. Okay, so in an arithmetic sequence, what's the difference between each term? D is the difference. In a geometric sequence, what happens in a geometric sequence? Well, what do we have before? We had 1, 2, 4, 8, etc. We don't have a difference here because see the difference here is 1, the difference here is 2, the difference here is 4. The difference doesn't work for geometric sequence. What we say is the ratio between each of these numbers. What's the ratio between 1 and 2? It's 2. What's the ratio between 2 and 4? It's 2. What's the ratio between 4 and 8? It's 2. So what we say is R is the ratio. And these things help define sequences in series. Tn is just the nth term. T1 we call A is just our first term. Okay, I'll just write that there. First term. The arithmetic sequences have a difference between each number, and a geometric series have a ratio. And there's sort of all the bits and pieces we need to know. And I'll come back to this now because I needed to do that first. So just a new page, and I'll come back to that same sequence again. So let's, now that I've just defined a few things, 4, 7, 10. I should have done that first. That's okay. You'll bear with me, won't you? How can we define this sequence? Well, there's two ways, and I'll do it here. Just divide the page up into two ways. Okay. The first way is to define it in terms of the previous term. Okay, so let's just have a look at this. What this means is, let's have a look at Tn. In this sequence, each number, you add 3 as you go along. We're adding 3, adding 3, adding 3, adding 3. And so what we do, at each term, we just add 3 to the previous term. So if you want to try to find this 7, how do you find this 7? Well, you look at the previous term and you add 3. How do you find this 10? You look at the 7 and you add 3. So at each step of the way, what we do is you look at the previous term, so Tn minus 1, so the term before, and you add 3. So this defines this set here. All you do to find one of the terms, all you do is you look at the previous term and you add 3. So that's a way to define that. Can you see how though we don't know where the sequence starts? We don't know what number to start at. And so it's always helpful to say what term 1 is. So in this case, term 1 is equal to 4. Okay. We could also say that's A. Okay. Either way, A or T1 is both are acceptable. A is probably a bit better. So this defines the term. So if you look at this, if you wanted to know what we already know what T1 is equal to 4, what's T2 equal to? T2 is equal to the previous term, T1, plus 3. What's T1 equal to? So that's 4 plus 3, which is 7. What's term 3 equal to? Term 3 is the previous term, term 2, plus 3. What is T2 equal to? T2 is 7. 7 plus 3 equal to 10, etc., etc. That's the first way to define a sequence. The second one is to define it in terms of n. And this is much more powerful. Let's have a look at this. So what we've got T1 is equal to 4, term 2 is equal to 7, term 3 is equal to 10, term 4 is equal to 13. Can we write a rule where Tn is equal to something? Okay, is there a relationship between the n, in other words that number there and that number there? What's that relationship? What's the relationship between this number and this number? And this is what we're looking for. And if you look at them, well, they all jump by 3. And so it's going to be, you can see how we're going to have to multiply that number by 3. So 3 times n. If you look at this, if we times 3 by 3, you get 9, but this answer is 10. In this one, it's 2 times 3, and so it's going to be plus 1 to get the relationship between those two numbers. And this is a much more powerful way to define the sequence. Why is it more powerful? Because say you're asked to find T36 or something like that for this sequence. If you wanted to use this way in terms of the previous term, then you'll have to find what T35 is and then add 3 to it. Then how do you find term 35? Well, then you've got to work back and you've got to look at the 34th term. How do you find the 34th term? You've got to look back. So this can be a very tedious way to do it. But if you're asked to find T36 looking at this one, then you go, oh, well, T36 is just 3 times 36 plus 1. And so it's a much faster way. You can just do that in your calculator, easy. So this is much more powerful. And so if you can define it in terms of n, much better than in terms of the previous term. And I'll do more in the next video.